G'day YouTube, Warbles on a lot here. Reading from Father's Day. When I was a little lad, the 1960s that would be, while driving through the tablelands, my father said to me, "It's a worry, son, see there, the topsoil's gone." And he'd ponder long while the erosion went on, and we drive down the hill to the sea. Reading from Wherefore. Topsoil, topsoil, wherefore art thou topsoil? Mostly washed out to sea or wind blown away. What remains is going salty or compacted underfoot. There's bugger all true topsoil hereabouts today. Topsoil, topsoil, wherefore art thou topsoil? Where there once was creek beds neath invading willow trees, now it's rank and swampy bogs of topsoil under subsoil, slumped there where tall gum trees used to be. Mountain topsoil, wherefore art thou, mountain topsoil? Left hereabouts long time gone. High rocks grow faster than their moss, fringed with blackberry and bracken, thistles and briar, feral goats, pigs, cats, fox, rabbits, plus domestics. Ecology lost. Table landscape, wherefore art thou, table landscape? Watching, waiting, and hoping, in remnant pockets small. Seed stock, maybe for recovery, stays alive from day to day, awaits industrial barbarianism's self-constructed fall. Okay, now let's hear what the radio has to say.
Welcome to Big Ideas. I'm Paul Barclay. Matthew Evans was a top chef and restaurant critic when he noticed something amazing. A homegrown carrot could taste better than one served in a five-star restaurant. It led him on a journey to find out why. Now, he's a farmer and an author bent on sharing his latest passion, soil.
Topsoil, I just think it was inert, so it didn't have any life in it, and it was essentially just something to get rid of from under my nails. And, that it was important to wash it off the potatoes so they didn't taste dirty. But that was about it. I had no clue. But feeding is just one of the things it does for us. Soil can affect climate, it can affect weather, it can affect our mood, it inoculates our immune system. It's sort of endless. The more I read about soil, the more I went, what? And this is stuff that it doesn't exist in our cultural imagination. No poets are writing things about soil, are they?
Soil's vast ecosystem is the genesis of almost all the food we eat and air we breathe, yet we're fast degrading the best of it. Matthew Evans' new book, Soil, explains how each of us can replenish this incredible resource while growing superb food. I spoke to him for the Byron Writers Festival. Matthew Evans, welcome to Big Ideas and this virtual Byron Writers Festival discussion.
Well, thank you so much for having me, Paul. I tell you what, I'm looking out the window at the frost and thinking, Byron, would have been attractive in more ways than one this morning.
So I'm speaking to you on a Sunday morning, and as you say, it's a bit frosty outside in your neck of the woods. What does a Sunday morning on the farm look like? What have you been up to this morning?
I've been out milking cows, feeding pigs. Oh, I had French toast with my family. So not that dissimilar to other people, except for the milking and feeding pigs.
And the fact that you're probably cooking food that has been grown on the farm.
Yeah, very much so. So I put some beautiful Jersey cream and soured that, put some yogurt culture in there and soured that so they could have sort of this lovely, slightly acidic cream on my French toast with a bit of apple syrup. We boil down apple juice from our heritage orchards and make it a really condensed syrup. Sort of like maple syrup, but in apple-grown regions, you do that with apples because that's what you got.
Our mouths are watering, Matthew. Onto your book, Soil. You managed to get us to think about something that most of us rarely, if at all, ever think about. We think about trees, we think about CO2 in the atmosphere, we might even think about agriculture generally, but we almost never think about soil itself. Is soil underrated, do you think?
Yeah, it certainly is. And I think part of the reason I wanted to write about soil is because 10 years ago, as someone who tried to grow food for a couple of years, I started to sort of get interested in why certain things were better and get interested in soil generally. And the stuff I found out about soil just blew my mind. Like, if you weighed all the trees and all the plants on Earth, and all the animals on Earth, that's all the stuff that we see. Soil stores 6 times more carbon than that. So when you plant a tree, yes, the tree has some carbon in it, but it's actually soil doing the heavy lifting, but we don't see it. And in fact, if we can see soil, it's damaged. Bare earth is damaged earth or dying earth. But the soil beneath our feet, a single shovelful of healthy soil, is more biodiverse than the entire Amazon rainforest. And Amazon rainforest is the most biodiverse ecosystem on land.
Yes, no, there's some incredible kind of descriptions of soil in the book. There are more living things in a teaspoon of soil than humans on the planet. Billions of living things, and as you just said, then a shovel of soil has as much biodiversity as the Amazon rainforest. What is it in the soil that is living?
Yeah, it is a living, breathing ecosystem. The top 20 centimetres of soil exchanges all its gases, the oxygen and carbon dioxide and other gases every hour. So it is actually breathing everything. We think of it as quite solid. So what's in it? The living things, well, mostly it's bacteria, fungi. So we think of fungi as mushrooms, that's the fruiting body, but most of the fungi is underground and these fine filaments and threads that go through the soil, connecting plants and managing things underground. We have nematodes, little microscopic worms. You have protists like protozoa, algae. You have these little things called springtails, and there's this great website, Chaos of Delight, which is this guy photographs what's called mesofauna. They're colourful, they're cute. There can be 13,000 of them under a single step in the forests of America. That's how dense this ecosystem is that live in soil.
And we'll pick up on some of that. But when did you first realise the importance of soil?
I grew up in a family that didn't grow a lot, so I wasn't really a grower. And when I started to grow things, I wondered why one patch of my garden would grow better than another. And I'd go, oh, this stuff tastes really delicious. And we're not very good growers. We weren't then. And so why does this taste delicious, and why does it taste better than the shops? And then as we grew over more years and looked after the soil in the same patch of land over more and more years, the stuff got more delicious that we took from there. And I thought, well, what's that about? Like, why? I get the same rainfall, it's the same geology, so that 95% of soil is crushed up rock. So the crushed up rock is the same today as it was 10 years ago. Why do my carrots taste better today than they did 10 years ago? What has changed when I live in the same part of the world with the same sunlight and the same rainfall? And what's changed is the biology in the soil. And so what we've done is got more life within the soil, which has changed the way our things grow. But more importantly to me, because I'm a chef by trade and a glutton by nature, is that I've actually got more delicious food on the table by looking after the biology of the soil, the living things in the soil.
Yeah. In order to tell this story, I suppose we should firstly remind the listener that you are a kind of unlikely farmer, an unlikely agriculturalist in a way, or at least on paper that seems to be the case. You were living in Sydney, working as a chef in restaurants, in some fancy restaurants. You were a food critic, and then came this big lifestyle change. What drove that?
Well, most of my life has been driven by my desire to eat either more or eat better. I was eating in really fancy restaurants, and they were saying how good the produce was because they'd spend the money and they'd take a lot of time to find good ingredients. And I was saying how good the ingredients were, but then I met home growers, and you're sitting in at someone's kitchen table, eating a lettuce undressed, no salt, no pepper, nothing except the raw ingredient. Going, hang on, this lettuce tastes better than Australia's most expensive restaurant. So I started to think, well, wow, what's that about? And I got interested in why some things taste different to others, and I thought, well, that's the grower. And so I thought, well, I'd like to have a crack at growing. And where I lived in Sydney, it wasn't possible to have 3 chooks or a little garden. So I moved to Tasmania, almost accidentally bought a little farm in southern Tasmania, and suddenly I had more than 3 chooks. I had 10 chooks and 3 sheep and a dairy cow and a really big garden, 2 pigs, which became 10 pigs, which became 15 pigs.
Yeah, it's interesting, that story. A long time ago, read this really interesting story about a classically trained French chef who went to live in Greece and lived on a property in Greece with a family. And she was an incredibly acclaimed chef, but she said that she realised that she understood food for the first time, living with this family in Greece who grew their own tomatoes, their own olives, made their own bread, their own lettuce. And she said, coming up to the lunch table, after they'd picked basil and lettuce and sliced up the tomatoes and the freshly baked bread came out of the oven, she realised that she understood what food was about for the first time, homemade olive oil. And it was the flip side of complex French cooking, but she realised in a sense that was what the essence of food is about.
I trained as a chef when I left school, and I went to fancy restaurants because I thought, wow, chefs are making great food. And then I realised actually, growers are actually making great food, and chefs hopefully don't stuff it up. And when that woman was in Greece, she's essentially tasting that patch of the earth and the biology within that earth, and how they nourish the soil that nourishes them.
So you did always have an interest in the provenance of the ingredients that you were using when you were a chef in the city?
I like to say I did. Yes and no. Chefs are busy.
Yeah.
I was busy. No. If I had, especially with meat, if I had an idea of how some of the things were produced, I probably wouldn't have used them. What I love now, 15, 16 years after I left Sydney, is that when I look into the cities now, there is this great focus on where things come from. Who grew this? What's happened with that thing to make it better? And that seems to be creeping onto restaurant menus. It's there a lot more than it was. Certainly when I trained in the early 80s in Canberra, Provenance wasn't. We used to cut up the stalks of silver beet and put it in Mornay sauce and call it fennel in Mornay sauce because no one knew what fennel tasted like. That's sort of how far Australia's come. We're doing really well compared to what we were.
Yeah, no, look, I live just around the corner from the Victoria Market in Melbourne, and every day when I do go and shop there, I reckon I see at least one ingredient every day that I don't know what it is, such as the diversity of food that's on offer. I mean, you make no bones about the fact that you were a pretty poor gardener when you moved onto the farm. You didn't know a lot about growing plants. How did you learn to tend a veggie garden and produce the food that you now produce on your farm? Was this a case of trial and error, essentially?
Yeah, very much so. So when I lived in Sydney, when I first thought, I'd like to grow more. I couldn't grow anything in the yard behind where I was living. It was overshadowed, just grew moss and snails. So I got a plot in a community garden. It was in a churchyard, and my plot was about the size of a grave. And I can tell you, Paul, I sent a lot of plants to the grave in that particular little plot.
I know the feeling.
The only thing I nourished was parsley. And I'll be really frank, I'm not the gardener on our farm. My wife is the gardener, and we have professional gardeners who work with us. I'm still rubbish at it. But what's really amazing is when you have a crack, so there are a few things you can learn early on how to grow food. And a carrot seed's destiny is to become a carrot, right? That's what it is designed to do. So if you can put some conditions in place where it fulfills its destiny, then you become a successful grower. So it's, in some ways, even a Gumby like me can be successful way more often than I would have thought. So about 95% of the time, I reckon, when we first started, we would never research it properly because we would just launch in and find out what's going on later. And 95% of the time it worked. And the 5% of the time is when we probably learned so much more than when it was successful. When you fail, that's actually when you learn. But nature wants to grow, like a mother pig wants to raise healthy piglets. A carrot seed wants to become a carrot. A seed potato wants to become the next year's crop of potatoes. And so if you can work with what nature is trying to do, you can be successful enough as a grower. And we were lucky enough to live in a society where if it doesn't quite work out with that crop, we have shops, and most of us are able to afford to go and supplement what we can grow with stuff that we haven't managed to grow. Outside my window, I can see right now where the possums have come in and stripped all of our house gardens vegetables, because we have a market garden down the road which is well fenced. Our house garden isn't. We thought it would be fine, but we've lost our entire winter harvest to the native wildlife.
Actually, I should locate you. Your farm is in the Huon Valley, not far from Hobart. You've got some pigs, chooks, cattle, sheep, goats, ducks, and a small restaurant on site, about a 30-acre family farm tucked in a gully. Is that about right?
Yeah, it's about 70 acres.
Okay.
There's probably about 30 acres that's left for wildlife and creeks and stuff like that. But yeah, it's a mixed farm. And the other thing is we don't have ducks. We only have one duck, and she's named Joanne. Oh, and we milk some cows.
Okay.
Yeah, we have beef cows and dairy cows. Yeah, but apart from that, yeah, you nailed it.
Sounds like a beautiful part of the world anyway. There's so much interesting in the book about soil. You say that, and I think this applies to me as well. You say that you thought that basically how plants grew was that they ate the soil. That's clearly not actually quite what happens. But can you explain to us, because you do in the book, how soil helps plants to grow and therefore creates the food that we eat?
Yeah, this was a real mystery to me, and I guess it starts with photosynthesis. So when a plant captures the sun's energy, when I was at school, I can't remember the teacher's name, but it was fairly boring. They taught us about photosynthesis, and I probably dozed off because that's what I did during science. But the message what I got was when a plant photosynthesizes, so the green in the leaves, it captures carbon dioxide out of the air and releases oxygen, and in this beautiful synergy, we breathe in oxygen and breathe out carbon dioxide. So plants help us to breathe by getting rid of the carbon dioxide and releasing more oxygen for us to breathe. And that was the message I got. But actually, really, that's kind of a little bit about what plants do. But really what they do is they create sugar out of thin air. So a plant takes in carbon dioxide and turns it into carbohydrates. So using the sun's energy, photons of sunlight, it turns carbon dioxide with a bit of water into carbohydrates. So they make sugars out of thin air. It's a total miracle. And that living, breathing superorganism, the ecosystem around the roots of a plant, they can't create their sugars. Just like you and me, we need to eat something that's already lived to survive. We can't create sugars out of thin air, and sugars out of thin air are energy in digestible form. So there's things around the base of a plant, they need those sugars. So what happens around the base of a plant, and you're right, plants don't eat dirt, but they need things that are in the crushed up rock, and they need biochemicals that are created around the roots of the plant. They need those to thrive. So yes, they can create sugars, but they need calcium, and they need iron, and they need magnesium, and those things exist not in gases or in water, they exist in the soil. And how do they get them? Well, they're made available to the plant by the action of the microbes. So most of the bacteria in soil, the biggest concentration of them is clustered around plant roots. Because what plants do is they can put out messages saying, I need more phosphorus, or I need more iron, or I need other things from the soil, and the microbes can find them. So fungi can stretch much further away from the plant than the roots go. They can actually communicate with other microbes. Fungi can actually strangle these microscopic worms, these nematodes, sort of put out little loops in their structure and strangle nematodes and suck the nitrogen out of them and feed it to the plant. Well, why would the fungi do that for the plant? Well, they do that because at least 20% of the sugar that a plant creates, they feed to the underground ecosystem. They essentially dribble out sugars and amino acids, the building blocks of protein, and lots and lots of other things into the soil to feed the underground ecosystem. And in return, the underground ecosystem finds what the plant wants. And it's this beautiful symbiosis that happens wherever you have living plants and living soil. There's this amazing exchange of nutrients, of biochemicals, and there's also this ability to communicate, which we're sort of on the cusp of understanding how plants communicate, not only with other plants, but can communicate with the microbes in the soil to get what they need.
Tell us a bit more about that, about how plants communicate with one another via the soil.
Yeah, so most of that we think is driven by fungi, and I'm not a great expert in this, but Suzanne Zimmer from the US, was studying trees and trying to work out why, she was looking as a forester, and why certain trees would, if you planted a single species rather than two species together, the single species didn't do as well. Did a whole bunch of research, discovered that fungi, fungi, the things that we think of as, fungi can be yeast, it can be mushrooms, but the vast majority of fungi are soil-borne. They've put out these fine threads called hyphae, and they're really tiny. They're so fine, they can be about 1/60th the width of a root hair, a plant root hair. But they're so fine, there can be 10 kilometres of them in a teaspoon of soil. This stuff is sort of mind-blowing. But those fine threads are able to carry messages. So a plant can communicate with another plant. So say passing giraffe eats a plant, they can communicate through the air, through putting out pheromones, but they can also communicate through the fungi at their roots to other plants further away to say, watch out, I'm getting eaten. Change the structure of your leaves to put out a tannic chemical or a different chemical to make yourself less attractive to the passing giraffe. So it's not each tree for themselves, it's trees looking after each other. Older trees and sick trees can actually take the energy out of their structure and feed it to younger trees using fungi generally as the mechanism. And it's this beautiful thing, that idea of survival of the fittest, that everything's trying to kill each other. Well, a lot of the time things are trying to help each other because there's this mutually beneficial. And we're certainly finding that. They call it the wood wide web, and now we know it's actually happening in grasslands, it's happening in under shrubs, it's happening everywhere. It's just easier to research in trees.
Incredible. Also incredible is the fact that almost all of the calories that we consume come as a result of topsoil. How is that?
Yeah, so that energy that the plants create, that's essentially the genesis of all energy that's available to us as humans. Now, a little bit comes from the oceans. The oceans, the poets write so much about the oceans. The oceans are big in our cultural imaginations, but really, in terms of how much energy they provide to us, to humans, 1 to 2% of the energy that humans need comes from the oceans. The rest comes from green living plants creating sugars out of thin air. We can eat those plants, or we can get animals to eat those plants, and eat the animals. But that's the genesis of all, pretty much all the food that we eat. And so without topsoil, then we're kind of stuffed. So, this stuff, I used to think that topsoil, I just think it was inert, so it didn't have any life in it, and it was essentially just something to get rid of from under my nails. And, that it was important to wash it off the potatoes so they didn't taste dirty. But that was about it. But in terms of what else it does, I had no clue. But feeding us is just one of the things it does for us. Soil can affect climate, it can affect weather, it can affect our mood, it inoculates our immune system. It's sort of endless. The more I read about soil, the more I went, what? And this is stuff that it doesn't exist in our cultural imagination. No poets are writing things about soil, are they?
That's true. It's true. There is a big difference, though, between good soil and bad soil. What is bad soil lacking in?
So bad soil, the definition of bad soil can be quite complicated. Because soil isn't, when you look at soil, the mass of soil, so the weight of soil, 95% of it is crushed up rock. And where you live, it'll be different than where I live, which would be different to the top of the hill that I can see out my window to the bottom of the hill. And so it's a bit of a geological lottery in terms of what you've got. And you can get bad soil because essentially you live on too much sand and you can't hold on to nutrients or water. You can have bad soil because you've got too much clay. So sand, silt, and clay are all forms of crushed up rock, essentially just crushed up rock. You have those three, and you have no life in the soil. You have 5% of the weight of soil is organic matter, and that's things that formerly lived. So they could be bacteria and worms and nematodes that have died. It could be leaf litter or dead roots that have been stuffed off the bottoms of plants. And that's really important as a home for the living things and as food for the living things. So good soil generally has about 5% organic matter, things that formerly lived, and of that 5%, about 1% of the total mass of soil at most, is living things. So everything from worms down to protists to bacteria and all the other things in between.
Well, as you write, Charles Darwin observed that worms contributed the dark organic matter that we find in healthy soil, the stuff we call humus. How important are worms in soil, and what do they do to bring health to the soil?
Yeah, worms are amazing. Imagine, Charles Darwin, father of evolutionary history, theory, and spent his last 20 years researching a book on worms, and I think his contemporaries thought he was mad. So what he was interested in, when he went on his long journeys around the world, he had a paddock that he looked at that had stones that were sort of sitting on the surface of the paddock. And then over time, those stones disappeared into the earth. essentially soil grew over the top, and they sunk into the earth. He was trying to work out what did that. And so he looked at worms because they were the easiest thing to see, even though we knew there were microbes in soil, like bacteria and other small organisms. He looked at worms as the heavy lifters, I guess, because you could see them, and he measured how many were living in soil. And worms are remarkable because they pass through the earth. They can move where a lot of things can't, like a lot of the small animals, the mesofauna, the springtails, they can't move through the soil very easily. Bacteria can't move through soil at all, but worms can move all the way through soil. So they're constantly moving things around. They're ecosystem engineers. And as they're doing that, they're aerating soil because they're creating these lovely holes through the soil, and that allows the soil to breathe. And because the things in the soil are just like us, they need to breathe. They need food, they need water, they need warmth, and they need oxygen. So that allows that to happen. And then what comes out the back end of worms is essentially like a superfood for plants, like a growth promotant for plants. It helps to create soil structure. Parts of it help to dissolve rock, so to make the minerals that are trapped within rock more bioavailable to the plants that live in the soil where the worms are. And his book, it's this beautiful, you can find it online, a copy of it online, and it's this beautiful little, relatively short, and it's scientific, but it's not a hard read. And it's this celebration of these squiggly, ugly, slimy things that any home gardener will get excited about when they show you they'll lift up their compost or a patch of their earth, and if they find a worm, they giggle with glee because we kind of know that earthworms are important, and it took someone like Charles Darwin to say, oh my God, they're not just important. We have enough of them in soil. They're doing way more than you can do with, in those days with the horse and cart, in terms of actually aerating soil and nourishing soil and moving soil around, but moving soil around in a way that doesn't damage it, which is the difference between, I guess, the plough and the mechanical means that we use and what an earthworm can do.
Well, yes, I mean, just onto that, the state of our soil in Australia now tells us a story about how we have treated it, how we have farmed our land since European settlement. We've lost an enormous amount of our topsoil since we arrived, haven't we? I think, almost half of our topsoil?
Yeah, the estimates, this is quite amazing. We've lost between about 40 and 60% of our topsoil since Europeans arrived. So topsoil is the magic bit. That's where the 98 to 99% of our calories come from. Plants can't grow where there's no soil. So this is the bit that does all the world's growing. And in Australia, we've lost somewhere between 40 and 60%, so say half, of our topsoil in 200 years. And we're estimated to lose the next half in the next 40 or 50 years. And we're not blessed. We don't have 2 metres of topsoil or 30 centimetres of topsoil in most of Australia. Parts of Australia only have 1 centimetre of topsoil. And in a best case scenario, nature can make about 12 centimetres of topsoil in 1,000 years, but most of Australia, nature makes soil, by breaking down rock and, by microbial activity. In parts of Australia, it takes 1,000 years to make 1 centimetre of topsoil. So when you lose half of it, your centimetre, if you've got 20 centimetres of topsoil and you lose half of it, you can still grow good stuff. But if you've got 1 centimetre of topsoil and you lose half of that, you're kind of in trouble. And I think we're in a parlous state, really.
Sounds kind of apocalyptic, actually, when you put it that way. So what have we done wrong in how we've practiced agriculture that has led to the diminution of topsoil?
Yeah, look, there are lots of culprits, I guess, but the worst is agriculture. But I just want to frame this, like farmers aren't bad people. They've just been trying to grow food and using the technology that's available to them. And the technology that was most available to us for the last couple of 100 years, in the last 100 years in particular, artificial inputs, so artificial fertilizers, the plough, and fossil fuels that allow us to move the plough around a lot quicker. And then probably the worst of all is the plough. The estimates are that if you look at increased carbon in the atmosphere, so that's the thing that we, the human-induced global warming is based on carbon in the atmosphere, between a quarter and a third of that increase has come from soil, directly from soil. How did carbon get from the soil into the air? Well, all those billions of living things that live in soil, if they die, their carbon can be released. And if you cut soil open, you can release the carbon in the dead stuff, the 5% organic matter or whatever you want in healthy soil. that can be released to the atmosphere. So up to a third of the current increase in carbon in the atmosphere is simply due to us releasing it from soil through a series of historical accidents and technological improvements that we may not, or that we didn't understand what we were doing at the time. So we've damaged soil without really fully understanding the implications.
I'm talking to author, farmer and chef Matthew Evans via Zoom for the Byron Writers Festival. The ground beneath us provides almost all the energy that sustains us. It grows our food and enables plants to give us oxygen. But Matthew Evans says we're treating the soil like dirt.
I saw a bookseller reading the book the other day, and he said to me, "I hope it's got a happy ending," because there are some grim numbers in there. When you're losing topsoil globally 30 to 40 times faster than it's made, it's a bit apocalyptic. But we have the technology to build soil. Some of that is historic knowledge. So we know that humans have created fertile soil 7,000 years ago. 7,000 years ago. That's a long time from a farmer's perspective and from a human's perspective. Soil that is still fertile 7,000 years later. We know parts of West Africa have created black earth, these beautiful dark earths 700 years ago that are still fertile 700 years later. So we've got that knowledge. We've also got techniques. So instead of having to plough land, we now have ways of sowing seed directly into the soil, into the ground, without having to turn it over. So when you turn over soil, you're essentially, if you think of soil as a living, breathing superorganism, it's not one organism that matters, it's the interconnectedness. If you think of it as a living animal, you wouldn't scrape all the fur off the hide of your cow and expect it to live. You wouldn't cut it open and expect it to live. And it's the same with soil. If you cut it open, you damage it. So you can drill seeds directly into the soil. So they call it direct drilling, and that has halved ploughing in many parts of the world. So we're getting better at stuff like that. But the other thing is, what soil does best with is green living plants all year round. And so every photon of energy that comes from the sun that lands on Earth is if it doesn't get taken up by a plant and photosynthesized, or if it lands in the ocean, can do other things, but the one that lands on land, if it doesn't land on a plant that can photosynthesize, it's lost forever. That's energy that's lost forever. If it does land on a plant, then we have the technology and the ability to manipulate ecosystems, so to plant the right plants. We're not talking GM or anything particularly complicated. Well, it's complex but not complicated. We plant the right plants that can feed soil and grow topsoil way quicker than nature can. So we have this technology using sometimes the big tractors and the fossil fuels, but also essentially using living plants, ways to cover earth, ways to grow crops that can not only not damage the earth as much, but actually replenish and grow topsoil at rates way beyond nature can ever make it. We can grow topsoil in 5 years. It might take nature, 1,000 years. But
incredible.
We use the knowledge we've got.
Wow, we can grow soil. There's another thing I've learned today. You mentioned earlier about soil storing carbon, and you write in the book how we should be increasing our levels of soil carbon. On the flip side, though, how is soil being affected by climate change itself?
Yeah, climate change is a tricky one because in Australia, I think you're starting to see a lot more talk about soil in Australia because we're at the forefront of this. We're on marginal soils, thin soils, old soils that are leached of nutrients. And so a place that was borderline to grow 10 years ago may not be possible to grow next year or the year after. So the things in soil hate to dry out. They need moisture and they need warmth, but they need to have cover. So bare earth is bad. So whenever we get an extended drought and all the living green matter dies, it's bad. These temperatures that we're getting in sort of inland Australia, that are breaking records, are really hard for soil because soil and plants coexist. So one doesn't exist without the other. So when we talk about soil and think about soil, it's good to use plants as a sort of reference point because they give us an indication of what's happening in soil, and they feed soil and create soil. So when we don't see green living plants, so when we see bare earth, when you hear about a so-called dust storm, I call them soil storms, blowing topsoil, blowing stuff around. that's our topsoil vanishing over to the ditch between us and New Zealand, even staining the glaciers of New Zealand. And this didn't happen much prior to the 1930s, prior to the wholesale use of the plough. And so climate change is bad for soil in that way. There are some things about climate change. Increased carbon in the atmosphere actually helps plants grow a bit quicker. Like they get bigger quicker, they can get more volume, but they actually become less nutrient dense. There are some slight pluses in some areas in terms of increased carbon in the atmosphere, but from a human nutrition point of view, it's generally a negative. And from a farming perspective, on these areas that there are huge populations of the earth are reliant on sort of marginal land. If that becomes, soil reaches a tipping point, and climate change is not helping.
I spoke to Charles Massey, who wrote that brilliant book, The Call of the Reed Warbler, and he writes about how he revolutionised his agricultural practices. He switched to what we call regenerative agriculture, got rid of the chemicals, destocked his land, cut back on ploughing the soil, and the results were just breathtaking. He said, not only did the birds come back to the land, and this one bird in particular that hadn't been seen, I think, for 100 years, but he was running less stock on the land, but his land was both healthier and more profitable. Amazing story. It sounds a bit like you've been on a similar journey with your farm. Have you, along the way, kind of changed, modified your farming practices, tried to regenerate the land?
I moved farms a few years ago, so we had a farm for a couple of years, threw everything at it, and then got my dairy cows and my sheep and my pigs, and I turned a lot of good soil bad in a very short period of time. Overgrazed, overtrampled. I'm not proud of it, and I think, like Charles, a lot of people who've grown, who've reached a point of, some people have a personal tragedy or apocalyptic event like a fire or something like that. We just had this realization that we are custodians of this patch of land for a very small amount of time in geological terms. Farms, while a lot of them are privately owned, we think of them as the national asset, and we need to be responsible. So we've changed our practices a lot over the years, and they're constantly changing and trying to improve. It's now, after 10 years of owning this land, we see beautiful changes that, I've seen different animals here, different bird calls, different insect populations, and the health of the soil. We know the health of the soil is at the bedrock of that. So we're focused on here, whether I'm growing parsnips or grazing dairy cattle, the health of the soil is what we focus on. But what we see is this increase in biodiversity across the entire farm. I have to drive really slowly up the driveway so I don't hit bandicoots and quolls. And as far as I know, they're pretty much extinct on a lot of the mainland. And here, we're trying to avoid them on our own driveway because they're sort of taken over the place. And it's this really beautiful thing. And our neighbours, some of them have similar practice, others don't. And the ones that don't give us a nice reference point to see how our land has changed over the years, because it's hard to tell what you've done without a reference point. And photos help, but you're not always sitting around looking at photos. But if you look over the fence and go, oh, their paddocks are browned off a bit earlier, a month earlier than ours, why they've got the same rainfall, why are they not green anymore? Well, it's soil. It's something in the soil that's happened, and it's nice to think that humans can change soil. And we're essentially rank amateurs at this, but even then, like growing food, you can do amazing things just by caring a little bit.
Well, you do put this into the bigger historic picture, actually, and you, in the book, talk about the Green Revolution and how it changed agriculture from the 50s and 60s onwards, increasing crop yields for wheat and rice in order to feed the growing planet. But the result, of course, was a decline in the nutritional value of crops as a result of this, and more to the point, in crops like, I suppose, rice and wheat and so on, but more to the point, an increase in the use of fertilizers and pesticides, which has been quite devastating. This has not been good either for the soil or our waterways, has it?
No. When I grew up, I don't know if they still teach it at school, but the Green Revolution was, this miracle thing where we fed the world. And what it did, they changed plant varieties so they could grow them more efficiently, and they grew plant varieties that would grow with artificial nitrogen. So nitrogen is nearly 80% of the atmosphere. So and it's a superfood for plants. Plants grow. It's the main nutrient that plants need. So give a plant nitrogen and water and sunlight, and it'll grow bigger quicker. And so it seems really good. You're growing more crops to feed the world. The problem is you can grow crops on areas that shouldn't have grown crops. You can grow, when you use artificial nitrogen, it kills the soil life, or at least puts it to sleep, damages soil in the long run. And nitrogen is released into the atmosphere as nitrous oxide. It's about 300 times more warming than carbon dioxide. And it also goes into waterways. So something like 70% of New Zealand waterways are unswimmable because of nitrogen runoff from, predominantly from dairy farms. Sure. So, it's, and there are huge areas of the world that are dead zones in the oceans from nitrogen runoff. And so, and it comes at a cost to get reactive nitrogen fertilizer to put on crops. It's about, you burn natural gas, you burn a fossil fuel. So about 2 to 3% of the world's carbon emissions come from burning the gas to make the nitrogen, to put on the crops that releases the nitrogen oxide that poisons the waterways. Now, I'm not, absolutely against artificial nitrogen. It might have a place to kickstart some growth in some parts of the world, but we use it wholesale, polis bolis. About 1 in 2 mouthfuls of food that you eat is the result of artificial nitrogen, and it essentially kills soil in the long run. And so we have to wean ourselves off it, and we have to work out better ways to do it. The amazing thing is those bacteria and things that live in the soil, some of those can trap nitrogen from the air without burning natural gas, and they can feed them to plants. All your legumes, your peas, your beans, your clovers, they actually have an association with bacteria under the soil, and they fix nitrogen. They take a nitrogen out of the atmosphere and store it in soil in a plant available form, without burning any natural gas, without having to truck things around to spread it with your tractor, without it poisoning waterways. So we have natural ways to do this, but how can you scale that up, and how do you manage that? That's where the technology, we have the technology now, we have to be able to implement that. We have to have the will to implement that.
Well, look, you're on a farm in this idyllic part of Tasmania, but of course most Australians live in the cities and in the suburbs. I live in the inner city in Melbourne. We've just put some large pots and planter boxes in the outdoor spaces here. We're growing some trees, some citrus, some kumquat, lots of herbs and leafy greens and so on in our very small scale way, and I should say with some help from people who know what they're doing. How important is urban agriculture, and what is the soil like in Australia's big cities?
Yeah, so cities typically are built on places where there was really good soil. They grew where there was food readily available, and so they're built on really great farmland. And I did some maths on this and added up all the urban areas and the roads and what we've built on, and we've covered an area of the earth, roughly the size of Western Europe. If it was a country about I think it's the 7th biggest country, I think I worked it out, to be covered with cities and urban areas and roads. Now, that has been lost to agriculture. It doesn't grow stuff anymore. But, and this is the big important thing, it isn't actually lost, because you can have things in pots. You can have things on vertical gardens on your balcony. You can have a backyard garden. You can have a rooftop garden. And currently, a billion people feed themselves from domestic gardens around the tropics. So people who live around the tropics, they have up to 100 different species growing in their gardens, which is amazing in and of itself. And they feed themselves entirely from those domestic gardens. So that's a billion, it's 1 in 8 people currently feed themselves from domestic gardens. Southern Tasmania, Melbourne, we're a little bit harder to grow things all year. We have very lean times because it's not as warm. It's not the tropics. But we can all do something to grow food. And I think the beautiful thing is that everybody can take control of the soil that's near them. So whether it's a pot plant, even if you're just growing something to give you pleasure, just to look nice on, in the house, or whether it's some parsley to put on your pasta, whether you've got a little plot, a little garden area where you can grow some silver beet and some carrots or whatever. Every bit of soil matters, and when you take that into your own hands, you will see how humans can build soil. You will realise very quickly how humans are capable of making soil, because that's what home gardens do. How much better it tastes, how much better things are fresh from the ground, and I guess it gives you hopefully a little more appreciation for the soil in the bigger sense of for the people who are trying to manage 50 acres, 500 acres, 5,000 acres, and grow food on your behalf, because farmers are just growing food for you, and they will look after it if we encourage them and pay the true cost of production.
I've got some friends who have an apartment in Berlin that I visited just before the world went crazy as a result of the pandemic, and they've got this, Berlin's a pretty dense city. They've got this tiny balcony on which they grow potatoes, of all things. You also mentioned that you met a woman who grew carrots inside her flat in polystyrene containers. There's something wonderful, isn't there, about people growing their food and with these limitations, but still being able to produce it.
Yeah, and I think that's what this woman really inspired me. She said she was growing carrots. I thought, oh yeah, so how big's your garden? She said, I don't have a garden. And how big's your flat? And so how big's your balcony? I don't have a balcony. And yet that she had found a little sunny corner in her kitchen, in her flat that didn't have a balcony, that she could grow carrots. It filled me with wonder. It's easy for us. We've got 70 acres. I can find the sweet patch of the soil, the north-facing bit. I've got 7 dams I can take water out of. And really, what we're doing is nothing compared to what she's doing. And I think that's what's inspirational. Is everybody has their constraints. Everybody has their. It doesn't really matter where you live. Doesn't really matter. What access you have to other people's land. You can actually take a little bit of soil within your control and do something with it. And when you do that, there are microbes in soil that release happy hormones in your brain, so you can actually get like almost an antidepressant effect from working in the soil in your little tending your little plot. You get something to put on your plate, gastronomic joy, feel good about yourself mentally, emotionally. If you've got a bigger garden, it's good for your back. There's so many good things about being able to tend a patch of soil and take something from it, and particularly put it in the kitchen. But even if you just grow some flowers to burn up your living room, what's better than that?
I just wanted to talk a bit about animals. You graze some animals on your property, beef cattle, dairy cows you mentioned before. How do animals affect the soil, especially cattle, which we know produce methane, which is a dangerous greenhouse gas?
Soil is designed to be around animals. So soil and plants and animals coexist. That's how everything evolved. So prior to 700 million years ago, it was pretty much just bacteria and archaea and a few fungi, not much. And then when plants came along, we got soil, and very shortly after, we got animals, because animals are, I guess, a conduit between the plant and soil. They eat the plants, break them down, and move nutrients around. And so generally, all the soils on Earth are used to having animals on them. We lost a lot of the nutrient cycling, so nutrients get moved from place to place by animals because they're so much more mobile than plants, and we don't want nutrients moving with wind, because that's means that you've damaged the soil, and that probably wouldn't have happened much in nature. So animals move nutrients around. When we lost our megafauna, the really big animals, about 12,000 years ago, a lot of them died out around the world. We lost about 92% of our nutrient cycling, so how nutrients get moved from place to place. And a lot of landscapes are designed to have nutrients move from the low points to the high points. So nutrients typically move downhill, because that's what gravity does. So if you have a paddock or a garden without any animals, all the nutrients and the fertility moves downhill. But animals move the fertility back up the hills. So essentially they're replenishing the stocks of nutrients. So when I can see some cows outside my window at the moment grazing. We use them on our property because there's lots of our land that's not suitable for growing other things. And one of the beautiful things about animals, is that it's grazing animals, ruminants, so cows, sheep, goats, they have a full stomachs, they ferment things. What I'm watching my cow eat at the moment is grass. Now, the most abundant carbohydrate on Earth, so plants create carbohydrate, but the most abundant single carbohydrate on Earth is cellulose. And sadly, for you and me, it's not digestible to us. So we can eat grass, and we'll get a little bit of fermentation going on in our stomach, but we can't live off grass, and it's not digestible by us. Ruminants can digest it, and they can turn it into human-grade foods. They can take something they can't eat and turn it into something they can, into meat or milk. And in the process, yes, they burp out methane, but there are things that living in the soil. Actually, they live in the soil. They thrive in the soil much better below the mouth of the animal that's grazing it. Things that there are bacteria in soil that eat methane, essentially called methanotrophs. I'm watching my cow eat. I know that part of the methane that it's burping out is being digested by the healthy soil, by the microbes in the healthy soil below its mouth. And the methane is a result of carbon cycling. So carbon can be stored in soil, it can be stored in plants, it can be stored in the air and in the oceans. And so my cow is just part of a cycle where the carbon and methane's made of carbon. It's just moving around between those things. It's a bit different if I introduce fossil fuels into the mix, so if I fertilise my paddocks using fossil fuels, because that carbon, because fossil fuels are also made of carbon, that was carbon stored underground, 50 million, 300 million years ago, when the atmosphere wasn't very conducive to not only the ruminants but to us. So watching my cows graze, yes, they burp out methane. It's a self-sustaining system. If we have too many of them, yeah, it's probably bad for my land. It's probably bad for the world, but they're not in and of themselves evil, I guess. They have a purpose in some farming systems sometimes.
Well, your previous book looked at eating and farming meat. Dare I say, soil is rather less controversial than that. And clearly you are a conscious farmer, an environmentally conscious farmer, thinking about what you do, learning from your mistakes, trying to improve your treatment of the land and so on. But you quote Joseph Poor, who wrote an influential scientific paper some years ago, and he said famously that a vegan diet is probably the single biggest way to reduce your impact on planet Earth. It's far bigger than cutting down on your flights or buying an electric car. Now, this is a statement that you take issue with.
That statement's from his press release, not from his scientific report. And I think that says it all. If he has a belief system that he was trying to back up with a scientific report, but his scientific report doesn't back up that as fact. So I don't care whether people eat meat or not, but I guess where I take issue with it is if you're releasing fossil fuel carbon into the atmosphere, that's like it's a one-way street. But if you're grazing an animal that is eating grass and cycling carbon between soil to grass to atmosphere to cow to soil, in this sort of endless loop, it's a different thing than releasing fossil fuel carbon. And drawing a direct line between the two, I think, is a bit disingenuous. So I take issue with it because I'd like people to make informed decisions. You're going to not eat meat, great. I couldn't care less. You're going to eat less meat, great. I think most Australians eat a little bit too much meat for the planet's health and for soil's health. But to make up stuff, to back up your science, I thought was a little bit disingenuous. And then it gets picked up because it's such a great statement saying, the best thing you can do, when it's not actually. I mean, I was talking to soil scientists yesterday. We were talking about growing lettuce, and she was talking about how bad lettuce is for soil health and how much carbon it releases. No one demonises lettuce. Everyone wants to demonise cows. I think it's just the easy kicking. It's easy to kick it, and you've got a group of people who have a belief system, and they find something that supports their belief system, and they sort of use it to help prop up the belief system. There are problems with ruminants. There are problems with methane. There are problems with overgrazing. There are problems with feeding human-grade food to animals. But not eating meat, and you can still flights from releasing fossil fuels is a little bit bending the scientific facts to suit a belief system, I believe.
So you're a producer. What about those of us who are consumers, who buy our vegetables, buy our meat perhaps as well, and who want to be ethical consumers, who want to help promote sustainability? Where should we get our food from?
Yeah, look, it's a really interesting one. So generally biodynamic and organic labels, those people generally have a better impact on soil. There are some labels coming out with biodiversity ticks. So saying this has come from a biodiverse farm. There's at least one supermarket supporting regenerative agriculture. So farmers who build regenerative farms, and they're doing that through soil health right through the ecosystem. So there are ways. One of the ways you can do it is eat a diverse range of things. Not everyone has the luxury to not buy at a supermarket, but farmers, what soil needs is not necessarily what we need. So what soil needs is diverse plants growing all the time. So a farmer will grow wheat, and then next year, if you want to eat more and more bread and crackers and pasta and whatever, they'll grow more wheat. Now, what the soil needs is not wheat that year. It needs millet. I'm not a grain grower, so I'll make this up, but millet or triticale or sorghum or something. And so, but a good farmer looking after their soil will grow that other thing, but then they can't sell it because you're not buying millet bread or sorghum bread or triticale bread or anything made with those products. So then that grain gets fed to animals. The farmer who doesn't care as much about soil will grow wheat every year. And because that's what you're buying. So the more diverse things you can buy and eat, the better. And we know that if you eat, and it works it's not just with grains. It's, don't just buy broccoli and carrots. Buy kohlrabi and salsify and parsnips, and diversify your vegetables as well. And that doesn't just help the soil. We know that if you eat more than 30 plant-based foods a week, and that can be as small as just a little bit of fresh herb on your casserole or whatever. If you eat more than 30 different plant-based foods a week, you have a much better autoimmune system than if you eat less than 10. And so you're not only helping the farmer, you're actually feeding your own little ecosystem, your gut microbiome, that helps you have a better immune system. So it's a win-win.
I spoke to Matthew Evans about his new book, Soil, for the Byron Writers Festival online. Thanks to the festival for their assistance. More information about Matthew and his books can be found at the Big Ideas homepage. That's a wrap. Thanks for listening. Until next time, bye for now.
Okay, well, yes, I had heard Matthew Evans speaking on a previous broadcast of exactly the same interview. Therefore, I was able to use the 5 minutes preparation time I had in order to pull out a copy of Bush Poems by Chris Wharton, which I printed in 1996, 25 years ago. You can chase up a copy at the Australian National Library, ISBN number 0646300674X. First poem in the book, Father's Day, 1966. 25 years is a long time. When I was a little lad, the 1960s that would be, while driving through the tablelands, my father said to me, "It's a worry, son. See there, the topsoil's gone." And he'd pond along while the erosion went on, and we'd drive down the hill to the sea. When I was a little lad, the 1960s that would be, I watched the last working bullocks snig the last muscle-powered tree. Dad photographed the bullocky whom the dozers had beaten at last. True selective logging finished that day, and the die was fully cast. Mighty piston-powered technology, the method now which we can see. When I was a little lad, the 1960s that would be, we'd go to the coast 3 times a year to an estuary by the sea, and we'd eat all the fish that a belly could wish, though they were rather small and would fit on one dish. And the old man said, "That's not the size fish used to be." When I was a little lad, the 1960s that would be, with every glance the old man saw, it always seemed to me ruin and waste. The land's resources were squandered in haste. He watched the ground all around while the world raced in space, and his tips on how things used to be, he passed those on to me. When I was a little lad, the 1960s that would be, as the old man was showing me how to live, it never occurred to me that as I watched and I grew and the changes went on, so the world I was learning to live in had gone. For the old man, you see, was 52 summers older and wiser than me. And wherefore, on page of the 29, it was pretty much because of my having written and printed a book of poetry raving about topsoil in 1996 that in 1997 the Environment Centre Armidale invited me to accept the post of being their poet in residence. And I asked if it would put anybody's nose out of joint. They said no. I said, "Have you got a poet in residence, a previous one?" They said yes. I said, "Well, aren't they going to get upset?" They said, no, don't worry about it. She's really, really old and she hasn't written anything for years and she doesn't do any public appearances. It'll be fine. So I accepted the position. Turned out, I discovered later, I was replacing Judith Wright, who was a founding patroness of the Environment Centre at Armidale. Okay, so the other poem about topsoil, about which Mark Evans was unaware when he wrote his book about soil. He was so unaware that he made a point of mentioning 3 times during his hour-long interview that there was no poets writing about topsoil. So forgive me the faux Shakespearean pentameter. Titled Wherefore. written on the 23rd of the 4th, 1995. Topsoil, topsoil, wherefore art thou topsoil? Mostly washed out to sea or wind blown away. What remains is going salty or compacted underfoot. There's bugger all through topsoil hereabouts today. Topsoil, topsoil, wherefore art thou topsoil? Where there once was creek beds, neath invading willow trees, now 'tis rank and swampy bogs of topsoil under subsoil, slumped there where tall gum trees used to be. Food plants, wherefore art thou food plants? Selectively grazed and so killed out within 5 years. Seed stock gone, land burned out of season by arrogant fools. The land lice killed the food plants. Seems nobody cares. Rainfall, rainfall, wherefore art thou rainfall? Raindrops used to come aplenty regular, not just now and again. But then there used to be tall trees here, all clear felled mostly, for economic gain. Mountain topsoil, wherefore art thou mountain topsoil? Left hereabouts long time gone. Highland rocks grow up faster than their moss, fringed with blackberry and bracken, thistles and briar, feral goats, pigs, cats, fox, rabbits, plus domestics, ecology lost. Table landscape, wherefore art thou, table landscape? Watching, waiting, and hoping, in remnant pockets small. Seed stock, maybe for recovery, stays alive from day to day, awaits industrial barbarianism's self-constructed fall. Wherefore? Wherefore art thou? Part of the solution or contributing to the problem? Food plants. Food plants. Food plants. Food plants. Food plants. Wild native food plants. Sheep farm. Bare rocks. Edge effect on the boundary. Of the endangered species sanctuary. Inhabited by the fool on the hill, more or less, so to speak. So I guess what I'll do now is upload this to YouTube and then ring the local ABC radio station in Tamworth and suggest they have a bit of a look at it and have a bit of a laugh at it and contemplate the fact that 25 years ago somebody was in fact publishing poetry about topsoil and the vanishing thereof. Hearing that. Warbles on a lot to YouTube. Poetry of topsoil. Ciao.